According to the Georgia Performance Standards, 8th graders should be able to describe how heat can be transferred through matter by the collisions of atoms. This is called heat conduction. If you remember in our last class, we discussed the process of convection. Today, we will learn the process of conduction, which occurs between two objects. Be sure to take notes because you will see this information again at one point or another. Before we begin, let's ask ourselves one question. How can we find out? That's right. How can we find out? Thermal conduction occurs by means of the movement of particles in a material, mainly electrons. Let's begin by taking a look at this.
One example of conduction is the sensation one gets when walking barefoot across hot sand. Your feet become extremely warm or even burned as the thermal energy of the sand is transferred to your feet.
Now we know when a substance is heated, its particles gain energy and vibrate more vigorously. As particles bump into each other, the heat is transferred from the warmer substance to the colder substance. Let's look at a variety of examples of thermal conduction that occur every day. When a cold aluminum skillet is placed on a hot stovetop, the skillet becomes very hot due to the conduction of heat from the burner to the skillet. You decide to touch the handle of the skillet after it has been on for several minutes, and now the handle is hot too. This is because heat was conducted through the portion of the skillet in contact with the stovetop all throughout the rest of the skillet. When a shirt is placed on an ironing board to be ironed, heat from the iron is conducted to the shirt, making it easy to iron out all those unsightly wrinkles and make the shirt look sharp. These examples of heat conduction are designed to give you a better understanding of how the process of thermal conduction occurs. All metals to varying degrees are excellent heat conductors because their atoms or molecules have loosely held electrons. Some excellent conductors are cast iron skillets, aluminum pots and pans, soda cans, silverware, and silver coins. Poor conductors delay the transfer of heat and are known as insulators. Some examples are wood, wool, straw, and styrofoam. Today we've talked about the process of thermal conduction, where and how it might occur, and excellent and poor conductors. Now let's step into the lab and conduct an experiment that ties it all together. Okay, so here we are in the lab. We're going to conduct a little experiment here. What do you think is going to happen when I lower the balloon on top of the candle? Okay, so let's find out. Woo, that scared me. This time, I've added a little water to the balloon, and I'm going to lower it down to the candle. What do you think is going to happen this time? I'm going to lower the balloon toward the candle and count to 5. Feels a little warm underneath, but that's because of the water inside it. The heat from the candle is being transferred into the rubber, and then the water on the inside, which is absorbing all the heat. Water takes the heat from the rubber and prevents it from popping by the process of conduction. Let's see what happens when I lower the balloon all the way. I hope this video explains any doubts you have about thermal conduction. So be ready in class tomorrow for a discussion.